All right, Mr. Ahmed here for factoring for day number 4. This is actually the easiest one. Some special cases. We're going to factor the difference of two perfect squares. So just a quick reminder, square root means what number times itself is that number. So the square root of 36 is 6. Okay. The square root of 81 is 9. Technically, it could be both positive and negative 9, but since it's indicated as just a positive number for this, we're just going to leave it at that. The square root of 16 is 4. And the square root of x squared is x. Now the 49y squared, the square root of 49 is 7. The square root of y squared is y. So that would be 7y. 7y times 7y is 49y squared. So the patterns that we're going to look at here with the difference of two perfect squares, this only works if it's a difference. Keep in mind that means subtraction. Y squared is a perfect square, and 16 is a perfect square. So essentially, we're looking for factors of the last term, the constant 16, that add up to 0. And the only way that's going to happen is if it's a perfect square. So that would be like the square root of 16 is 4. So that would be a plus 4 and a minus 4. Now, y times y still gets us our y squared. And 4 times 4 is 16. Positive times a negative will get us our negative. And those will cancel out the middle term. Okay, so these are actually super easy. The difference of perfect squares. So we're just going to notice when we see two terms, a lot of times that's what it's going to be. So I notice 81 is a perfect square. X squared is a perfect square. Set up my two sets. X squared of 81 is 9, so we need a plus 9 and an x minus 9. 9 is also a perfect square. It's a difference. We're good to go. If this is a plus sign, this does not work. It cannot work with a plus sign, only with a minus. So n square root of 9 is plus 3 and n minus 3. Square root of 4, square root of z squared. It's a difference. Perfect squares. Z plus 2 times z minus 2. The square root of 1 is 1, so that is a perfect square as well. So for this problem, we can take the square roots, set up our two sets, p plus 1 and p minus 1. This one's a little tougher. 25m squared. 25 is a perfect square, so I can take the square root of it. Square root of 25 is 5. So I would have 5m plus 6 and a 5m minus 6. On our next one, the perfect squares that we're going to be working with. We're looking at an x squared and a 49y squared. So as I take the square root of these, the square root of x squared is x. The square root of 49 is 7, so I have a plus 7y. And then we'll take the square root for the second term. We'd have x minus 7y. I just have a couple problems left on this video, so I'm going to finish making it real quick. All right, on the next one, square root of x squared is x, so we'd have x. Square root of 81 is 9, so we'd have a minus 9y. And an x plus 9y. It doesn't matter if the plus or the minus is first. Here, square root of 64 is 8, so we'd have an 8c. Square root of 16 is 4. 8c plus 4 and 8c minus 4. For the challenge problems, factor out the GCF first, okay? 2 goes into both these terms, so I can take out the GCF. Left inside would be 9n squared minus 4. Now I have the difference of two perfect squares. 2's still there. Square root of 9 is 3, so I'd have 3n plus 2 and 3n minus 2. And the same process here for the next two. Factor out the GCF first, and then you'll be able to keep going. I'll leave those two for you to try on your own. That's it for today. Have a good one.